Cardiac cycle is um, all the events that is taking place in the heart in one heartbeat. Okay, so we are talking about the electrical events. So I'm talking about the EKG, talking about the pressure differences, which causes the movement of the blood. So volume differences, opening and closing of the valves, and what else? And the flow of blood, right? So we put them all together and call it a cardiac cycle. So this is the physiology, ultimate physiology of the heart. So it is, we break it down into these 4 stages and call it, like different phases of cardiac cycle. So mainly we are talking about diastole, where everything is calm, the heart is at rest, it's filling up with the blood, it's relaxed, and the events that take place to contract the ventricles. We really don't talk about the atrial contraction because that's not really relevant, but ventricular contraction is a big deal, right? So we talk about how the ventricular contraction takes place to push the blood, right? So we will talk about volume of blood, how much volume of blood is going to go out of the out of the ventricles of the heart. So we will also talk a little bit about the pressures of the arteries that ventricles is pushing the blood into, namely the aorta on the left side and the pulmonary trunk on the right side. So for our convenience, we break it down into 4 different phases: ventricular diastole or filling, isovolumetric contraction, ventricular ejection or systole, and isovolumetric relaxation. So when we use this term isovolumetric, so at this stage, the ventricles are completely closed chambers, meaning as soon as you see isovolumetric, think of the valves as being closed. All the 4 valves are closed. So, so we measure the amount of the volume of blood, okay, in the ventricles at that stage. So just before contraction and then just before it relaxes. So just before contraction is called as isovolumetric contraction phase. So that contains the maximum amount of blood. Isovolumetric relaxation phase contains the least amount of blood. Okay, and that helps us in further calculations, which we will talk about in the next video. All right, so let's get to this. So imagine everything is calm, right? So there is no activity in the heart. The blood is flowing through the body and through the lungs and coming back. So blood flows passively from both sides, on the left side and the right side. It's passively flowing through the veins into the left and right atria, same amount of blood, same volume of blood on both sides. It's passively flowing into the atria, about 70% of and the AV valves are open, so 70% of the blood just passively flows from the atria into the ventricles. At this time, the SA node starts to depolarize. So SA node depolarizes and the electrical activity reaches both the atria, right? The blood is passively flowing into the ventricles. At that time, following the P wave, following the depolarization of the atria contracts and pushes the rest of the remaining blood into the ventricles, right? So as the blood fills up the ventricles, the SA node, it has passed on, right? Its conductivity or depolarized wave to the AV node. AV node now starts to depolarize, and there is a little pause, right? And then it rushes through the ventricles. Once it reaches the ventricles, right, the AV valves close because the papillary muscles get depolarized before the ventricles do, and they will close the valves. So once the valves are closed, the ventricles are now closed chambers, right? And it has the maximum amount of blood called as end diastolic volume. Okay, so this is called as end diastolic volume. And the ventricles are now depolarized, right? And this is about to contract. Okay, so it hasn't contracted yet. So you have the T wave, QRS wave is completely innervated. So you can see the in the graph, you have the QRS wave, And at that time, the pressure inside the ventricles start to build up because it has depolarized, and then it is going to start contracting the ventricles. Once the ventricles start to contract, the pressure increases, and that pressure pushes against the semilunar valves. Again, it is happening in both the ventricles at the same time. So you have the same volume of blood in both the ventricles, and the ventricles start to contract. So as they're contracting, the ventricles, the pressure is still increasing. So as it is contracting, the pressure is increasing. When the pressure reaches the systolic pressure of the aorta and the pulmonary artery, the diastolic pressure of the aorta and the pulmonary artery, which is 80 and 8 mmHg respectively, then it pushes open the semilunar valve and the blood flows into the aorta and the pulmonary artery, and the pressure is still increasing till it reaches 120 on the left side and 24 on the right side, right? So as long as it is rising and it is equal to the systolic pressure, the blood will flow into the respective trunks, right, into the respective arteries from the left and the right side. And by this time, the ventricles have repolarized. So the T wave is completed. And following that, now the ventricles start to relax. Once they relax, the pressure is going to start falling down in the ventricles. So it is no longer able to match the pressures in the arteries. So the blood starts to flow back. And as it flows back, it fills up the semilunar valves, and you have that dub sound where it is closing, and the blood hits the valves and then ricochets back. So there is a slight increase in the pressure in the aorta and the pulmonary valve, pulmonary trunk, and that is called as dicrotic notch. All right. So and right again at this stage it is completely closed, right? So your AV valves are closed, semilunar valves are closed, and the remaining blood that is left in the heart is called as end systolic volume. Okay, so here it is. This is called as end systolic volume. Okay, so that's the remaining blood. So now the whole thing takes about 0.8 seconds, so it's less than 1 second. So atrial systole takes about 1 second, ventricular systole takes about 3 seconds, and then atria and ventricles are in diastole for about 0.4 seconds, which is when the blood is flowing through the body and through the lungs. That is called as quiescent period, and this total cycle is about 0.8 seconds, which is less than a minute, a second long. And blood flows due to the difference in pressure, and the pressure differences are caused by the contraction and relaxation of the muscles. So let's go and see this. So this chart, I like this chart because it gives the EKG, the heart sounds, the pressure in aorta. This is the left side. Then you have the atria, left atrium, and the left ventricle. The blue is left ventricle. So these are the pressures in each one of them. This is ventricular volume. So that is EDV, which is the maximum amount of volume. ESV, which is the least amount left in the heart. And what left the heart is called as stroke volume. Then you can see the valves open and closed. And then you have the phases, which is what is happening at each phase in the heart. So you can see that the first phase, which is called the ventricular filling, diastole. So here you can see that following the P wave, right? Following the P wave, the pressure in the aorta is falling, pressure in the atria is rising, and then it starts to rise, right? So P wave is only for atria. So you have the atrial systole, and then comes back again. Then you have the QRS. Following QRS, your pressure in the ventricles increase, and this is where the valves will open, right? So this is the valve for the AV valve, so that will open, and the blood starts to flow into the aorta. I'm sorry, semilunar valve opens. Semilunar valves open, Here it is. Semilunar valves open and your AV valve is closed. Otherwise, it's going to go back into the atria, right? So semilunar valves open and the blood floods into the aorta. So it keeps going till it reaches the systolic volume. And then as it is following the T wave, right? As it is following, it is going to close the semilunar valves. That is the dup sound that you hear. And the blood ricochets back. So there is a little pressure in the aorta, which is marked as dicrotic notch, and then pressure falls again. So this marks the maximum amount of blood, right? So as it is increasing, right? So that is your maximum amount of blood, EDV. And as it is going out, that is marked as ESV, that is the least amount of blood. Okay, so this is called as cardiac cycle.